Hi, this is Arslan. I'm back again with a new project on facial resurgery or facial reshaping for chin, cheek, and jaw implants. So, what is the need of this project? This project aims to develop or to enhance certain facial features and how a person will look like post surgery. So this is done using an affiliate tool called Abaqus. So what are the different steps of modeling this? So first of all, we need to generate a 3D image or 3D skin of a human face. You can create this 3D face using any sort of 3D printer. And I have used, or you can use 3G Magic, the software like GeoMagic to generate the STL file out of that 3D printed face. This 3D printed face is then imported to software called Abaqus, FE software for Abaqus, called Abaqus, sorry. So in this case, if you can see, this is the 3D image of the 3D STL file of human face, and you can see the skull portion. You can see the skull portion and the meshed skull portion created from a geomagic software. In the second case, we need to import the human tissues that are like 3D that are created using a 3D printing tool. So this is the face. This is the 3D image of 3D STL file of human tissues that governs the implant. And these are three different implants that we'll be using in our study for chin, cheek, and jaw implant. First, we need to assemble them, and for assembly, you can see over here assembly display option. Go to the display option. In this, I can show you. If I can show you, so these are three different implants that are. There are five different implants that we have kept inside the human face. So you can see over here. One is two of them are jaw implant. Sorry, one of them is jaw implant, two are cheek, and two are chin implant. And an inward displacement is given prior the start of the project. So in this case, we can see over here that these implants are placed inside the bone before the start of the simulation. You can see over here. These implants are placed inside the bone and there is no contact defined between the bone and the implant. It's a sort of just a free bodies placed inside another body. And after the contact, you can see over here, and in the simulation, we will be giving an inward displacement to these implants so that they can fit accurately the place of the we can place them accurately on the implant site. Now in the simulation I can show you how we are going to do this. So if I could show you the clear view of this. So okay, let me separate them, and now you can see I can show you in the displacement vector. This is how they are going to look like. Yes, so you can see over here. This is the initial position of these implants, and after we have given them an inward displacement, they are coming in the outward direction and they accurately fit the implant site. And you can see over here, they have accurately fit the implant sites. Now, what is the effect of this accurately fitting on the outer tissues? In this case, we have modeled the tissues, and you can see the role of the contact of the tissue and the now you can see over here. Let me, if I show you the cross-sectional view of this thing, so you can see these are four different implants. So these implants accurately fit the. So these are the initial location of the implant. If I can show you in the uh, where these implant, you can see these implants change the facial features and give an inward. Through this, we can give an inward displacement to these implant, and they can accurately fit where they belongs to. Similarly, in case of all these implants, let me show you. This is the first cheek implant, and you can, if I show you the closer view, it looks something like this. This is the initial location, and after giving the certain displacement, the equity fit the on-site. Similarly, now move toward the second implant. In the second case, I'll be showing you the initial locator of this uh, chin implant. So you can see over here, these are the initial location of the implant where the surgery. So when an inward displacement is applied, you can see they are giving an initial sort of displacement or push to the phase, and after that, in the first step you will giving the initial displacement to this implant, and in the second step an external force in the form of phase pressure is applied so that these implant accurately fit the uh, tissues, so there is no gap in between the tissues and the phase and the tissues and the implant. Now how you can change the now this is the face, this is cross sectional view of the human face, and you can see how accurately implants are in on the specific site. If you can see over here, similarly you can see the on-site location of the cheek implant as well. So an inward displacement is applied, and then this inward displacement is giving a push to the face, and after that an inward constant pressure is applied on the internal face of the skin so that these internal tissues accurately fit the implant on site, and there is no gap between the implant and the tissues. How are we going to analyze this? uh, Now, in this figure, you can see the comparison of of before surgery and after the implant. What is the change in the facial feature in both of cases? On the left, there is a face. This is a face without the implant being placed, and on the right, this is a face with the implant in place. You can see that the facial feature has been enhanced. You can see the chin and cheek has been grown, and on the side, on the chin side, you can also see a considerable bulging. So this is how, and then you can and after seeing the complete STL file or analyzing this STL file through using point cloud data or any other software, you can see the displacement of each nodes, and you can analyze that how a person is going to look like really after the surgery. So that's all from this video. I hope in future I'll come up with more exciting projects. Thank you. For further detail, you can visit my website aslan.com, and after visiting my website, you can click on I provide different services using different software like Abaqus, Autopipe, FESAP, Tosca, and Xflow, different FEAS design and modeling surfaces that I'm currently providing. And you can see my portfolio over here. In the design simulation project, you can see various projects related to heat transfer, soil modeling, geotech, civil and mechanical engineering. In order to access for a specific, if you want access related to a specific project, you can contact me by entering this form, by entering your name, email address, and the request and the name of the specific project, and let's just simply request, send me a request, and I'll share that project. Thank you very much for your time. I hope to see you soon.